So, sums and differences of cubes. Man, math 1, we've been doing squares. Sorry, guys. So, cubes. So that means x to the third power. So when it's a sum, hopefully we know that's addition. Differences mean it's going to be subtraction. The easiest, like I loved teaching this in class because I thought it was so ridiculous. So if you can remember SOAP, and you know where your cube root button is on your calculator, which is under math. I think it's math 5 if you're on a TI 83 or 84. If you're on Desmos, it's down in your functions. So when you open up your calculator, if you run over to the right, no, it's not. I'm lying. It's right there when you hit your calculator. I mean your keyboard at the bottom. So you just need cube root. I will say that this is another one of those 100 things that I've noticed. What happens is you are so used to taking a square root, you just take square roots for some numbers and force them into a thing. So cube root. So to the third. What number did I multiply by itself 3 times in a row to get that number that we're looking at now? And SOAP is where we're at. So it's going to be set up. So this is A, B. And when I say A, this is A. This is B. And then your second one is A squared, A times B. And now I'm not even sure if I'm telling you that right. B squared. Hold on, let me make sure I'm not messing this up. Yeah, okay, good. Whew. Yep. So B squared. And again, A and B is looking at this as AX cubed plus B. And then the SOAP part comes into play because it's same, opposite, always positive. So because this is sum, it's going to be add, opposite is minus, and this will always be addition in the back, no matter what, sum or difference. And then you're going to take the cube root. So to get x cubed, I multiplied by x 3 times. X times x times x. So that's going to go in the place of a. X squared, because it's a squared. And then I'm going to need an a here in the middle. Let's see if I can write this. Plus, minus, plus. Our b value, so 125, what did I multiply by itself 3 times to get 125? I don't know that. I think I'm too zoomed in that you can't see my calculator, but it should be 5. So 5 times 5 is 25, and 25 times 5 will give me 125. So that b value goes here. It goes right here. Oh, I definitely said 5, and I'm writing 125. Man, it is definitely time for Friday. So 5, 5, 5 squared. And then you're going to simplify it to finish it. So x plus 5 is in its simplest form. X squared minus 5 times x is 5x. Sometimes these are two numbers, not necessarily an x, or a number with an x and then a number without, or a number with 2 different variables. And then plus 5 squared is 25. Ta-da, you're done. So looking at another one that hopefully will be not too bad. And this is one of the ones you'll also pick up from what I've done this now for a couple of semesters. They use the exact same numbers over and over and over again. Like the perfect cubes are just like the perfect squares. But in this case, 8 times 8 is 64. And the misconception is a lot of people will put 8, and that's the square root, not the cube root. So again, it's a squared, AB. Whoops. See if I can get us over here. B squared. I think I got to back out a little bit. I write too big.
Wait, Miss Sigmund, are you solving or are you putting it in a different equation form?
You're just factoring it. So even when the parentheses portion, you're not solving it at all.
Okay.
No. If you had to solve it, you would set the 2 sets of parentheses equal to 0. And then your x squared, the quadratic form, the second one, the guy with 3 terms in it, you would have to factor it like a quadratic. Again, or use quadratic formula, or use completing the square. All of those things as well. But right now, we're just factoring at the moment. So it's addition. So same, opposite, always positive. So again, if nothing else, like in a classroom where I could stand over your head, if you didn't have this written on your paper, you would end up in trouble. Because at that rate, that means you've done nothing besides memorize SOAP. Trust me, the more you write down when you're trying to do it by yourself, and I mean, like, that's not an answer, obviously, but it's one step of the process that you've memorized. So if you are struggling, write at least that much down for every problem, because then you'll start slowly getting to the next part. So x cubed, the cube root would be x again. X squared, x times whatever we find out b is. So 64, like I said, the square root is 8, but that's not what we want. We want the cube root, which should be 4, because 4 times 4 is 16, and 16 times 4 would give me 64. So we're going to plug in a 4, and 4 squared. Then you just clean up and neaten up. Like, you don't want to leave it like this or necessarily like that, because that's not how they're usually written. That's not the standard form. So x squared minus 4x plus 16. Now you have factored all the way through. And the one so far, I think it was Robert that asked, the one so far, the reason we're not going any further into factoring is those back ones don't factor. But if you were to solve it, you would have to set this one equal to 0. You would factor this into two binomials, or use the quadratic formula to solve. Okay, so then going up one more, you also want to remember GCF and the possibility of a GCF, because there's not a cube root of 3. There's no number that I can multiply by itself 3 times and get 3. So we're in great hopes that 192 is divisible by 3. It is, which gives me 64. So that means I pulled out a 3. And now it's the exact same problem as the one before, except when we're done with it, we just have a 3 in the front. So again, that AB, same, opposite, always positive. And then you want to remember that 3. Don't leave it out, because it is part of the final answer for factoring. You have your x squared, x, and then again, the cube root of 64 is 4. And that 4 squared. I've also had a lot of students in the past, they stop right there. I can't give you full credit there, because that does not live like that ever, especially at this level of math. So x plus 4, x squared minus 4x plus 16. So same, opposite, always positive. Number 4, the same idea. 2 does not have a perfect cube root, so we're in great hopes that we can pull that out as a GCF. And I have found that a lot of Math 3 students, GCF is something that like stumps them up. Again, just let me know, and I will hit you with whatever you need. I'll send you more videos, or we can set up a time to get together and work on it. So a cubed, again, so we have a, b, a squared, so a, b, a squared, ab, b squared. It's still addition, so it's same, opposite, always positive. And I'm off the screen again. The cube root of a cubed is a. The cube root of 1 is 1. 1 squared is also 1. And for some of these, after you do a couple of them, you're going to be like, I don't need to write all this out. I get it. Or each step like I am, but for now, I want you to know where it's coming from. Then, when they get real hairy and furry, so again, they're going to use the same numbers that we've seen over and over and over. We just saw that the cube root of 125 is 5. The cube root of 27 we haven't done yet. But again, you just go to your calculator or your Desmos, and it's going to be 3. So even though this one looks wild, it's still the same idea. Might just take a little extra for cleaning up. So it's a squared, a times b squared. It's addition, so it's same, opposite, always positive. There's not a GCF with 125 and 27. So we're going to cube root 125. And that, remember, gives us 5. So it's going to be 5 and m, because m cubed. So it's going to be 5m squared, the whole thing squared. And then 5m. And then we're going to cube root 27, which is 3. 3 squared, and 3. Now, again, make sure we clean up all the way across. So 5m plus 3 is good. Nothing can be simplified. But 5m squared, the 5 is squared and the m is squared, not just m. So it would actually be 25m squared minus 15m plus 9. Now, for some of you, that's going to look crazy. Like, whoa, I'm not sure I even did that right. Like trying to square your 5m's or to multiply through. Since you have access to a calculator and Desmos, if you put your original function in your first line, and then you put this one, your factored function in the second line, they should graph on top of each other. If they do not graph on top of each other, that means you made a calculation error somewhere. So then you can go back. And if it happened to be multiple choice, graph the first one. And if the whole idea of factoring blows your mind, take the second one and put it underneath it and see if they, or all your answer choices, and see if that which one graphs on top of the other. Because theoretically, a factored form is just a different font of the same problem. So they should absolutely graph exactly the same. And then when it's in a different order, don't sweat it. This is your A. So it just becomes B, A squared, AB, B squared. And the A's and B squareds might flip as well, depending if they're positives and negatives. So bigger deal when it is a difference there, because then that A value is negative. So then B squared is going to be the cube root of 27, which we just saw was 3. I'm sorry, B is B3. And then B squared is 3 squared. It's addition, so same, opposite, always positive. For A is the square root of 64, which is 4. 4 times 4 is 16 times 4 is going to give me 64. So 4 squared, and there's that A with it, because that is an A cubed. This, again, is that messy one. And then that's 4A times 3. Then we just clean up. And in this case, they're both positive, so if you prefer the 4A in the front, out of just, that's how you've always done it, that's fine too. So 4A squared, 4 squared is 16. A squared. Negative 4 times 3 is a negative 12A. And then 3 times 3 is 9. And again, if you...
Could you do one where the A is negative?
Oh, yeah, we're going to get there. I'm just trying to beat your head in with the addition. Yep, next page is all subtraction. Yep. All right. Because we started at 9:40, right? Yeah. I'm trying to watch your time and be cognizant of your time. Okay, so differences. So again, it's the same thing. A, B, A squared, AB, B squared. The only thing that changes is same, opposite, always positive. So it's minus plus plus. Minus plus plus. Again, you're going to see the same numbers repeated unless there's a GCF is the only time. And then that should be one of your flags to know that there is a GCF, because it's a number that you haven't seen. But that's also whether or not you invest enough to do enough of the problems. So minus plus plus. A is going to be x, x squared, x. The cube root of 27, remember we said was 3. 3 squared. So our final answer is x minus 3, x squared plus 3x plus 9. So as far as like have to really think about positive negatives as you would in normal factoring, you get out of that as long as you memorize SOAP. Same, opposite, always positive. If you want to start thinking about positive negatives, how it's going to multiply back together, because you could also distribute or box method, or you can't really FOIL, this x minus 3 into that 3 again, and it should cancel each other out in the middles, and you should come back out with x cubed minus 27 when all the things happen. So another simple, straightforward problem, AB, A squared, AB, B squared. And I hope you notice that I'm writing that every time. And the reason I'm doing that for myself and for you is if you will do it for your first handful of problems, you will finally memorize that bad boy, how to set it up. And then again, SOAP gets you out of having to do a lot of thinking. You just have to remember to do cube root. So cube root of m cubed is going to be m. And then your cube root of 64, we did it already, and it was 4. 4 times 4 and 4 squared. Again, don't stop here because that's not everything simplified. So m minus 4, m squared plus 4m plus 16. Three, again, you can't cube root it, so we're going to hope that we can pull out that GCF of 3. And 375 is going to be 125 when divided by 3. And I think we did 125 already. Yep, 125 already. So 3 hangs out. A minus, because it's the same. Opposite, always positive. So our A value, remember, is x. X squared, x. Our B value, so 125, the cube root of 125 is 5. 5 squared, and then clean it up. So again, don't leave it in 5 squared and stop there, because that's a no-go. As soon as you see a 2, hopefully you know that also needs to have a GCF of 2. So 2 a cubed minus 64. And your GCF could have a variable in it as well. Like if you all of a sudden see it's a binomial and there's an a in the back and it's a to the 4th power in the front. Or if there's 2 a's in the back and it's a to the 5th power in the first term, then go ahead and pull those a's out, and then you can use difference or sums of square depending. And a cubed minus 64, I think we already did. We did a cubed plus 64. So minus, plus, same, opposite, always positive. We have our a squared, a. The cube root of 64 is 4. 4 squared. Yes, we did. We did it just right above it. Sorry. And I'm all the way off the page. My bad. And then, so 2 on the outside, a minus 4, a squared, plus 4a, plus 16. And I absolutely lied to you. I didn't print one where the a was negative because I'm not going to do that to you. I will show you next week if you want, or we can flip it. I don't know what would happen if I flipped it. We'll flip it and try. So 27 minus m cubed is what we'll do this one. So again, flip these guys. So the a and b flips spots. And all that does is it keeps you from having to factor out a negative. Otherwise, you would have to factor out a negative and switch everything. So then in this case, it's going to be same, opposite, always positive still. And we know that the cube root of 27 is 3, and that's my A value. I'm sorry, that's my B value. 3 squared, 3, because A is always attached to the variable. M cubes, we have minus, plus, plus. M cubed is our A value with a 1, so that's going to be just M. M squared. I'm sorry, I just told you that all wrong. It's 1. No, 1M. I'm right. Sorry. 1M. So then if we cleaned it up and finished it, and that answer, I'll be honest, like I said, I haven't seen them do that to you. It's a thing that this website that makes these worksheets does a lot. But what I would do is if it was in the other form, so in the A squared plus AB plus B squared, all they did was factor out a -1 all the way through. And so then that would make all the symbols all the way through switch if they flip the order. Hopefully that makes sense. Because if I factored out a -1, I'm making sure I'm explaining that right. This won't happen to you on my quiz for sure, but I would just stay with that one. And again, because you have access to Desmos, you can type it in the first line and then the second line. And that'll also help you understand if you've got your positives and negatives wrong. So if you do realize that they don't graph on top of each other, I would check on my SOAP, so the positive and negatives of things. And if you force the M in the front on this one, like I said, that shouldn't happen in our class. But then try there to troubleshoot first if it's one of those like that. Number 12 on this worksheet. So if we did this one straight up, it's just the differences again. A squared, AB, B squared. Same, opposite, always positive. A is 8. So what's the cube root of 8? 2 times 2 is 4 times 2 is 8. So we're going to have 2 squared, 2, and they have that A with it. Sorry, A and A. Yep. Then that -1, if we take the cube root of that 1, it's going to be a positive 1, because 1 times 1 times 1 gives me 1. 1 squared. So 2A minus 1. 2A squared, remember that's going to be 4A, and that's 2 times 2 squared, A squared, plus 2A, because 2 times 1 is 2, and 1 times 1 is 1. And you're done. That is all that I had planned for us to go over today.